Today I'm going to show you how you can use Microsoft Azure to fix a relayed Helium hotspot. This should help you if you've tried port forwarding and are unable to get it to work. It can also help for situations where you know that your device is behind cg-nat, or if you're using a shared internet connection in which you do not have control over the main router. An example of this might be a college dorm Wi-Fi. Also, I've been asked why they can't use a standard VPN provider or even perhaps another crypto-based project like Deeper Network for this. The simple answer is that these services do not give you control over the ports on the incoming connection side of the IP address. Hello everyone, I'm Admiral, and I have honestly just been having a blast in the Helium space. I created this channel recently to be able to help as many people as possible understand the Helium network and how they can use it to their advantage. One of the biggest things I've noticed is that so many people are excited about this project and eager to share their knowledge, but many people only understand bits and pieces of the whole picture. If you're excited about Helium as I am, I'd like to invite you to join our Discord. I'll be hanging out there doing my best to answer every question that comes along. You can find an invite down in the description below. I want to start off by saying that this topic was originally covered by Modo Tech, whose page you can see on the screen now. He does a great job of informing people how to get started in all kinds of tech projects. I've linked to his video on this topic in the description, so you can check out his channel and even join his Discord server if you'd like to learn about other projects. While helping people in Modo's server, I have noticed that there are some things that people are getting stuck on pretty frequently. In this video, I hope to help you understand exactly what the problem is that we're trying to solve, how we're addressing it, and some common pitfalls to avoid. I've posted the relevant links in the description for your convenience. So aside from a Helium miner, what is this going to require? First and foremost, you will need a hosted VPS, or virtual private server, that allows you to control incoming ports. I'm going to show you how to do this today with Azure, but it can also be done with other providers. Currently, Azure has my total projected cost to be approximately $26 USD per month per miner to cover the bandwidth. If you have got a well-optimized miner in a well-optimized location, then that expense will pay for itself in a single day. On top of that, the network will eventually move all miners to light hotspots, where the miner itself will no longer have the task of blockchain maintenance. And this is going to drive down the expense of maintaining this VPN considerably. The second thing you're going to need is a way to push the miner into a VPN. Since we don't have administrative access on our miners, we need something to act on its behalf. There are many ways to do this, but today we're going to try to keep it simple by using a small, affordable router. The important thing to note here is that not every router is going to be easy to achieve this with. For this video, I'll be using a GL-iNet Mango router, which you can see on the screen here now. If you decide to try another device, it will need to support running an Openvpn client, as well as allow you to manipulate the firewall rules for that Openvpn client. I highly recommend you also grab a second Ethernet or Cat6 cable instead of running your miner over Wi-Fi if at all possible. So let's get into it. Once you get logged in, if you don't see this page, you can just click Microsoft Azure in the top left-hand corner and it will bring you here. First, we're going to click Create a Resource, and then in this search bar, we're going to type OpenVPN. Click the first result, OpenVPN Access Server, and click Create. In the virtual machine name, I recommend that you use your miner's friendly animal name. No one else is going to see this, so it just makes things easier for you. For this example, I'm going to use Purple Tiger. And you'll notice that the resource group is named appropriately so that you don't get confused. Region for me was default at East US, despite being on the West Coast, and I haven't seen any problems with this, so it should be fine to leave at the default. Also on size, at 1 gig of memory, we're already seeing 80% utilization, so don't try to take this any lower or you'll experience problems. For authentication type, You can use SSH public key if you're familiar with that process, but for this demonstration, I'm going to use password. And make sure your username is something that you can remember easily, because there's a couple of usernames that you'll have to remember for this process. Here I'm going to use VPN admin and set a secure password, or it won't let you finish creating this virtual machine. Next, we go to disks, and on the OS disk type, we don't actually have a lot of disk interaction from this virtual machine, so I reduce this to a standard SSD, and then we click Next to Networking. We don't need to change anything here, so you can go again Next to Management. On this page, the only thing we need to look at is to make sure that auto shutdown is not checked. And that should be it for this part, so you can click Review and Create. Then you can click Create. Now this process can take a little while. It will initialize the deployment, submit it, and then you'll see a status here. Once it's complete, you'll get a link. Now that the deployment is complete, we can click Go to Resource. Now this is our virtual machine page, and this is also where we get our public IP address. Go ahead and hover to the right of it, and you can see that it says Copy to Clipboard. If you click that, it will put it into your clipboard for you. Then go to Networking, and we're going to click Add Inbound Port Rule. And for the destination port ranges, we're going to put 44158. For protocol, select TCP, and you can just rename this to 44158. Click Add, and wait here to make sure that it successfully completes adding this rule. Refresh the page to confirm that it shows up. And we can see that it is now here to allow 44158 to anywhere. Next, we're going to use Secure Shell to access the virtual machine. You can open a command prompt by pressing the Windows key, typing CMD, and pressing Enter. We're going to type SSH, and you're going to enter the username. VPN admin is what we used for this demonstration. And then you can right click here and it will paste the IP address that you copied from the previous page. You type yes to connect, and then you type your password. Now we're going to go through the initial setup process here. You have to agree to their software licensing. So type yes and press enter. You can press enter. Now we're going to press 2 so that we use that interface with the public IP address. Then we can press enter for the port selections. And we can press enter for pretty much all of these. Here at this admin UI Openvpn, you can change this username if you like. I just leave it at Openvpn. And just leave this part blank. When you press enter, it's going to start initializing the Openvpn process. Now that the initial configuration is complete, we can see here that the admin and client UIs are listed in the terminal. You can highlight these by just left click and drag, and you can copy them by right clicking. You can open a new tab and paste this into the browser, but don't go there just yet. Come back to the terminal, The next step is to set a password for the Openvpn administrator account. To do that, we type sudo space passwd space openvpn. It's going to ask you to enter a new password, and it will ask you to repeat that password, and you'll see that it updates successfully. Now that we've updated that password, coming back to our OpenVPN admin page, we should now be able to access this. And if you're on a different browser, this may look a little different, but ultimately we're wanting to go to advanced and accept and continue. Here we're going to use the OpenVPN password that we created. Agree to the terms here. And we are logged into the Access Server configuration page. This is where we will be configuring our VPN IP address rules for the user, as well as configuring the user itself for our router to use to connect to the VPN server. First, we're going to go to Configuration and VPN Settings. Under Static IP Address Network, we're going to click into Network Address and type 10.10.100.0. And under Number of Net Mask Bits, we're going to put 24. Scroll down and click Save Settings. Next, we're moving over to User Management, User Permissions, and this is where we're going to create our router's user login. Under New Username, we're using our friendly animal name to make things more simple, and for the demonstration, we're using Purple Tiger. Make sure to check Allow Auto Login, and then click More Settings. Set a password here that is secure, because it will be used consistently. Under IP addressing, make sure to click Use Static and then type 10.10.100.2. Scroll down again and click Save Settings. And at the top, click Update Running Server. This should be all that we need to do on this page. So now we're going to take off the admin portion and visit the user side. Remembering Purple Tiger, go ahead and log in, and you need to grab yourself auto login profile. That should download an OpenVPN file. Go ahead and save that. And if you haven't done so already, now is a good time to connect your GL-iNet router to power and let it boot up. While your router is booting up, we can go back to the Secure Shell terminal and configure the rest of the network configurations from the command line. It's important to do the OpenVPN access server before doing the network configurations on command line, because OpenVPN access server will sometimes overwrite those configurations, and that can leave you scratching your head not knowing what happened. I recommend that you just copy and paste these from the description so that you don't accidentally make any mistakes. It's important to only enter this command one time. If you have questions about this, again, visit our Discord and I'll do my best to help you out. So to paste into here, we right click and press enter. Next, we're going to issue a command that is going to make this previous configuration stay there, so we don't have to keep doing it every time. And what we're doing is we're installing the IP tables persistent package. It's going to take a little bit of additional space. It's okay to press Y and press enter, and then press enter for the save on current rules. You'll have to do that twice. Now that that's finished installing, we're going to issue this last command as a precaution just to make sure that everything is working as we expect. And again, just copy and paste this from the description. Press enter. You shouldn't see any other output, it should just be a blank line. And that should be all that we need to do from the terminal. Once your router has booted all the way, you should get 3 solid white lights on the top if you're using this Mango router. And you want to make sure that your internet cable is coming into this WAN port, the one on the left, and then your miner cable is going to go into the LAN port, the one on the right. Next, we're going to connect via Wi-Fi, and by default, all of these GL-iNet devices that I've worked with use the password GoodLife. Next, we're going to navigate to 192.168.8.1. And this is going to bring us to the setup page of the Mango router. Set a secure password. Submit. Now we should be able to go to wireless. And the first thing you want to do here is change your Wi-Fi key to something more secure than GoodLife. Once you have changed this Wi-Fi key and reconnected, you can go to Clients, and you'll be able to see here where your miner has been given an IP address automatically. My recommendation is to go ahead and copy this MAC address. And then the first thing we're going to go do is visit More Settings, LAN IP, and then we're going to put this MAC address in here. And I'm going to change this one to a .5. Click Add. To get this to update on the router, we need to reboot it, and this can take a moment, so I'm going to do that now. Okay, now we can go back to More Settings and LAN IP to confirm that this is still here. And then we can go to Clients and verify that it is in fact getting that IP address. The next step is to go to the Openvpn Client and to add a new Openvpn configuration. You can browse or drag and drop the file. I will drag and drop it here. Add a description and click Submit. Now we want to click Connect. This can take a moment, depends on your internet speed. Once it changes to show data received and sent, this should change over some time. And we can see that activity is going across the VPN tunnel. Next, we're going to visit VPN Policies. The purpose of the VPN policy is to make sure that anything else that connects to this Mango router will not be going across the tunnel. You only want as little going across it as possible. This also enables you to be connected to the Mango's Wi-Fi and still configure the terminal. So enable VPN policy and then disable these next two. This can stay as it is, same for the rules, and then you want to add your miner MAC address. Click Apply. And we now see that we have a green dot next to VPN policies, indicating that it is active. Next, we're going to visit Firewall, and we're going to add a Helium port forward here. Under Protocol, it needs to be TCP. The external zone needs to be Openvpn. Note that if you did not successfully connect to your VPN, this option will not show up. For external ports, we're going to put 44158. Internal zone is going to stay at LAN, and then the internal IP address is going to be the .5 that we set statically. Internal port is going to be 44158, and we're going to click Add. So to recap, what we've done in the Mango router is gone to the wireless, we changed the Wi-Fi password so that it's more secure. Then we came to clients and we checked for the MAC address here. Then we went to the LAN IP and set that MAC address to a static IP and rebooted the router. We came back in, visited clients to make sure that this IP address was correct. Then we went to VPN Client. We connected with our client.ovpn file and made sure that traffic was going across the VPN tunnel. We then came to the VPN Policies to make sure that only the miner was using it. And then we went to the firewall and set the port forward from the VPN to the miner. Now to check that everything is working, as long as your Helium hotspot is connected, you can go to portchecker.co and you can put 44158 with the same IP address that you used for the Openvpn server here. You click check and it shows open. Now that it's open, relayed status should go away on your device within the next couple of days.
Hero, I wanna be a hero.